What's up, future CPAs? If you're a BS accountancy student staring down the Management Advisory Services, or MAS, section of the LEGPA, you are in the exact right place. Welcome to this explainer. Today, we aren't just going to sit here and memorize cost accounting concepts, right? We're going to do a complete 3-year brain hack session to absolutely master cost estimation and regression techniques. We're optimizing your studying for maximum long-term retention. That way, when you actually sit for those board exams in your second or third year, this info is just instantly accessible in your mind. So, here's the mental map we're building today. 1. The mixed cost dilemma. 2. The high-low method hack. 3. The Scattergraph check. 4. Least-Squares boss level. 5. Accuracy stats. And 6. A rapid-fire LEGPA bullet review. All right, let's jump right into section 1, the mixed cost dilemma. This is our foundation. In the real world, and especially on the MAS exam, costs are rarely perfectly fixed or perfectly variable. They're usually mixed. So here's your very first study hack to separate those elements. I want you to anchor this exact formula to your brain, like picture it on a clean, crisp, white background, y equals a plus bx. Literally every single estimation method we tackle today is just a different way of trying to solve this one equation. Y is our total mixed cost, which depends entirely on our activity. A represents our total fixed cost, B is our variable cost per unit, and X is our activity level, like labor hours or units produced. If you can find A and B, you win the game. Moving on to section 2, the high-low method hack. It's quick, but it's totally flawed. So how exactly do we find A and B? Well, this first method is a mathematically objective hack using only 2 extreme data points from your historical records. You'll want to memorize these 3 steps for super rapid exam calculations. First, find your high and low points. Second, divide the change in cost by the change in activity to get B, which is your variable cost. And finally, plug B back in to find A, your fixed cost. But hey, listen up, because this is the crucial point, and examiners literally love to trick you here. We always select our high and low points based on the activity level X. Do not fall for the trap of picking the months with the highest and lowest costs. Activity is the driver, so activity dictates the high and low points. Okay, active recall time. Before we get to the answer, I want you to force your brain to analyze this. The high-low method is super fast, sure, but what is its fatal flaw? Think about it. What actually happens when we take an entire year's worth of company data, ignore 10 whole months of it, and only use 2 single data points to estimate future costs? If you guessed that it's way too easily distorted, you hit the nail on the head. The massive drawback of the high-low method is that it utilizes only 2 data points. And those points, they represent the absolute extremes of your operation, which means they can be highly unusual outliers. If there was some random, crazy spike in production that isn't normal for the business, your entire cost formula gets heavily skewed. That fundamental flaw is exactly why we need our next step. Which brings us to section 3, the Scattergraph check, visualizing the data. Before we even attempt any complex math, we have to diagnose the cost behavior. Take Brentline Hospital's data, for example. If we map all our historical data, like plotting patient days on our x-axis against maintenance costs on our y-axis, we can actually see the real behavior of the costs. A scattergraph plots every single data point to give us a visual reality check on what's actually happening on the ground. Plotting the data is an essential diagnostic step. What we're looking for is linear cost behavior. By drawing a line of visual fit straight through the center of all those plotted dots, we can use our own human judgment to confirm if a straight line relationship actually exists. Because think about it, if the dots are scattered randomly everywhere like confetti, it makes absolutely no sense to proceed to complex calculations. Okay, section 4, the Least-Squares Regression method. This is the boss level for maximum precision. Assuming our scattergraph actually does show a linear trend, let's level up. The evolution here is all about precision. The scattergraph relies on your eyeball and a ruler to draw a line of visual fit. But least-squares, it uses complex mathematical formulas across every single data point in your history to calculate the exact, statistically perfect line of best fit. You're going to want to lock down this exact phrasing for multiple choice questions. Least-squares mathematically determines the line of best fit by minimizing the sum of the squared deviations or errors. Basically, it calculates exactly how far each actual data point deviates from the predicted line, squares those errors, and finds the one line that makes that sum as small as mathematically possible. It produces the absolute most accurate a and b for our y equals a plus bx equation. Moving to section 5, accuracy stats. This is how we evaluate goodness of fit. So, we have this beautifully precise equation now, but how do we statistically prove that our chosen activity driver actually predicts our total costs with accuracy? Enter our accuracy stats, starting with the coefficient of correlation, which is denoted by the letter R. This measures the relative strength of the relationship between X and Y. And R of positive 1.0 means a perfect, direct, upward-sloping relationship. Negative 1.0, that's a perfect inverse relationship. And if R is 0, that means there's no apparent pattern at all, and honestly, your chosen cost driver is completely useless. But here's where it gets interesting. By simply squaring R, we get a percentage, which is our ultimate metric, the coefficient of determination, or R squared. Now, pay attention, because this is a heavy-hitting board exam trap. R squared tells you the exact percentage of the total variation in the dependent variable, the cost, that is directly explained by the independent variable, your activity. Let's make this totally concrete. If a multiple-choice question gives you an R squared of 92.16%, what does that actually mean? It means that over 92% of the variation in our maintenance costs is completely explained by our activity hours. The closer R squared is to 100%, the higher the goodness of fit. And that gives management, and you as the analyst, extreme confidence in using this formula for budgeting. All right, section 6, the LECPA bullet review. Time for some rapid active recall. Now it's time to consolidate everything into your 3-year memory bank. Just take a mental screenshot of this. Y is your dependent total cost. X is your independent activity driver. The high-low method always pulls data based on activity extremes, never cost extremes. The Scattergraph relies on human visual fit, while Least-Squares calculates the ultimate line of best fit by minimizing the sum of squared errors. And finally, R squared, the coefficient of determination, is your ultimate measure of goodness of fit. Definitely revisit this mental checklist whenever you're doing your practice drills. Okay, you are now totally equipped to crush the cost estimation problems on the MAS exam. But let's end with a final provocative thought to truly test your analytical skills. Imagine a company's production volume suddenly triples overnight, just completely blasting past their factory's normal capacity. Will our mathematically perfect, least-squares validated regression formulas still accurately predict their total costs? The answer is a definitive no. And the reason for that is the relevant range assumption. This is your critical reminder that even the most mathematically flawed regression analysis is only valid within a specific, normal band of operating activity. Push beyond the relevant range, and the rules of the game completely change. Keep that assumption in the back of your mind as you continue your CPA journey, trust your structured study methods, and keep pushing forward. You've got this.